Welcome to Ansys Tutorials by Civil Thinking, and in this class we will analyze another problem in Ansys Workbench 2024. Now before I move on, I suggest you to please watch the video lectures on Ansys Tutorials one by one in sequence as in the playlist so that you understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now coming to the today's class, in this class we will analyze a multi-member truss in Ansys Workbench 2024. Okay, now if you remember, in the previous class we have analyzed only two member truss. Okay, and in this class I have decided to increase the complexity so that you will get even more deeper understanding how the answers work. Okay, so let us first talk about this. Now you can see this is a 2D truss. Okay, now you have all these forces on all the nodes on the below members, right, except the first and the last. In the first and the last we have pin supports. Okay, now keep in mind they are pin supports, they are not simply supports. If you put them as simply supports you will get an error in the answers. Okay, so keep in mind you have to put them as pin supports with only degree of freedom along z axis. Okay, because this plane it is xy plane, right? Because this is x axis, the horizontal is x axis as you can see, and the vertical is y axis, right? So it means the z axis is perpendicular to this plane. Okay, and the truss can rotate, okay, in this plane about this pin. Okay, in this plane, since it can rotate in the plane, it means it have only 1 degree of freedom, that is it can rotate along what, the perpendicular axis or the z axis. Okay, so let us do the analysis one by one. We know the steps. First is to create the material, second is to create the geometry, then we will assign the material to the geometry, then we will do the meshing. Okay, then we will apply the end conditions, which are apply the supports and the forces, and then we are good to get the results which we want. Okay, so let me open the workbench 2024. Okay, here our workbench 2024 is open, and we have to go to the static analysis, right? Static structural. So I will double click on it. So let me name this project as multi member truss. Press enter. Now let's first define the materials. So I will double click on engineering data. Okay, the structural steel is default, but our is not structural steel, so I will delete this. Okay, so I will click here to add a new material, and I will name it as material. Okay, and since the Young's modulus is constant, E is constant for the whole truss, so we have an isotropic elasticity here. Okay, so I will drag isotropic elasticity on this material and add the Young's modulus and the Poisson's ratio. Remember, I have told you the fields in the yellow, they are important to fill. Okay, now yeah, what is the value of Young's modulus? Young's modulus is 2 times 10 to the power 11 Newton per meter square. Newton per meter square is Pascal, right? So it is 2e11. Okay, so I will enter 2e11, and Poisson's ratio is 0.3. Okay, 2e11 and Poisson's ratio is 0.3, right? Okay, so I have created the material, so we will close this. Then we will go to the next step, that is geometry. Here we will create the geometry. So I will right click and click on new design modeler geometry and wait for the design modeler to start. Okay, here our design modeler has started. I will click on XY plane, click on look at. Okay, and also I will do some settings here in the grid so that I will get the graph like thing. Okay, and I will also click on snap. Okay, so here I will draw the whole truss. Okay, so let us see how to draw the truss. Now let us, you can see there are members along the x-axis. Here it is, how many members are along the x-axis? Let me count. 1 2 3 4 5 6, right? We have 6 members. Okay, we will first draw these horizontal members, then we will draw the vertical members, then we will connect them to get the other members. Okay, so we have to draw 6 horizontal members. They are 1 2 3 4 5 and 6. Okay, and each have the length of 5 meters, right? So I will draw 6 members. From here to here it is 1, then from here to here it is 2, from here to here it is 3, from here to here it is 4, from here to here it is 5, from here to here it is 6. So I have drawn the 6. Okay, 6 members. I will click on dimensions and specify the dimension of each. Okay, now here I will drag it down. This is h1, right? And I will drag it down. This is h2. I will drag it down. This is h3, this is h4, h5, h6. So these h1, h2, h3, they are what? They are the length, right? They are the length of each truss, right? So here we know the length of each truss is what? 5 meters, right? So I will add 5 meter to each. 5, 5, 5, 5, 5 and 5. Okay, now we have ready the horizontal members, right? Now what we do, now we will draw the vertical members. Okay, let us see. Now the vertical members start from the second node, right? And it end at the second last. Okay, so in them the first and the last vertical member have a length of 5 meters, and the mid members have a length of 5 plus 1 is 6, right? So the first and the last is 5 meter long and all other are 6 meters. Okay, so let's first draw the, okay, I just click randomly because we will specify the dimensions. Okay, it will adjust automatically. Okay, so we don't have to worry, right? How many vertical members we draw? 1 2 3 4 5. Let us count the vertical members. 1 2 3 4 and 5. Okay, so as I said before, the first and the last is 5 meters and the others are 6 meters. Okay, now let me go to the dimensions. Okay, I will drag it like this. This is v7, this is v8, this is v9, v10, v11, right? Now let us, here it is. v10 is here. Okay, it has arranged itself randomly. Now v7, you can see the yellow color, it is selected. So this is the first, right? It is only 5 meters long, right? Now v8, it is middle one, it is 6 meters long. v9, it is also 6, right? Then where are the others? We have 1 2 3 4 and 5, right? v7 to v11, right? Here is v7, v8, v9. Now v10, now v10 is what? v10 is 6, right? So here we have v11, it is 5, right? So let us check again. Now v10, it is the middle one, which is 6, so it's correct. v11, look at the yellow line, this, it is 5, so it's correct. Then we have v7, it is the first, which is 5, so it is correct. 6 is also the from the middle ones, it is correct. And this v9 is also from the middle one, it is 6, so everything is correct. Okay, now what we have to do next, we have to connect to make the other members, right? These oblique members. Okay, so I will connect all these, all the top Okay, so we'll get the oblique members, right? So let us do that. Here to here, here to here. Now the Ansys will automatically calculate these lengths. Okay, we don't have to specify their lengths. Here, here to here, here to here. Okay, so now what is remaining? Now we have to draw these, right? It is like from second member top to bottom, up down, down up down, down up. Okay, so basically I have to start from here. Okay, like this, then like this, then like this, then like this. Okay, now this is our sketch. Okay, now I forgot to tell you one thing. Why did I draw everything in sketch 1? I didn't create new sketch. Everything, all the work is done. If you see here, it is the sketch 1. Why I didn't draw other elements in the sketch 2? It is because all the cross sections are same, right? They have the same properties and the area is same also. Okay, that's why I draw them in the same sketch. Okay, then I will go to concept and click on lines from sketch and click apply. Okay, now it will create this line. Okay, then it is showing a small icon of generate. Okay, when I click on generate, you will see this line body has been created. Okay, now here this is the yellow field, it means it is demanding attention. Okay, now what is it saying? It is saying to specify the cross section. We have not created the cross section yet, so let's create the cross section. The cross section is rectangle. Let me show you here. It is rectangle cross section 0.1 meter times 0.1 meter, right? It is 0.1 times 0.1, right? So here is our cross section. Okay, now we have created the cross section, so we can assign it here. So I will click on rectangle 1. Okay, so we have created our line body, okay, successfully. So let us close this and move on to the second step. Okay, now what is the second step? Second step is the model. In the model, what we do, we assign the material and we generate the mesh. Okay, so I double click and it will start the Ansys mechanical enterprise. Let's wait. Okay, our Ansys mechanical enterprise has started and it has also imported the geometry. Okay, now let me see it in cross section. Okay, so that we can see the 3D. You can see how clean our truss is, right? Now let us go to the geometry. As you can see, it is already showing a note of interrogation here. Okay, so it is demanding attention. Okay, even if you don't know the steps, it will tell you. So I will click on line body, go down. Here it is showing in as yellow, so it means it is demanding attention, right? So when I click on the yellow, I will assign material. Okay, now in the mesh, I will right click and click generate mesh. Okay, so we have to wait until the mesh is generated. Okay, now you can see here the mesh has been generated. Okay, as you can see here, see how clean the mesh is. Okay, everything is okay, right? So now let us move on to the next step. Okay, let me close this. We'll go to the setup and wait for the Ansys mechanical to start. Okay, Ansys mechanical has started and our geometry is also imported. Okay, now what we have to do, we have to go to the environment and here we have to specify the supports. Okay, when I go to supports, remember when you want to create, the simply supported here. Okay, we don't need this. Okay, the fixed is here. We need a what you call as pin support. Okay, and you have to basically create the pin support. Okay, unfortunately in the Ansys program you don't have anything called pin support, but you can define any kind of support in here in this option. Okay, remote displacement, we will define our pin support. Okay, remote displacement, I will keep the vertex option selected and click on this because here is a support and click apply. Okay, Now I will, this is free, everything, these are the degrees of freedom. It has all the 6 degrees of freedom, right? X, Y, Z displacements and the rotation about X, Y, Z. They are all free, but I have to restrain all of them, right? I have to keep everything constant except the rotation Z, okay? So let us do that. Click on constant. The Y is also constant. The Z displacement is also constant. The X, the rotation X is also constant. The rotation about Z is not constant, right? Rotation Y is also constant, right? So let us check everything. Now I have kept this X component 0, Y component 0, Z component 0, okay? And the rotation X is 0, rotation Y is 0, and rotation Z is free, okay? So we have successfully created what? We have successfully created our pin support at this, okay? Now we need another here, so I will go again on the supports and click on remove displacement, click on this edge and click apply and do the same changes here, right? Constant, constant, Z component is constant, rotation X is constant, rotation Y is also constant, okay? So we have restrained everything and we have only kept 1 degree of freedom, that is rotation Z, okay? Now since we have done the supports, now we will apply the loads, okay? Now the loads are 1000 Newton. Remember, I have to write them, they are only in Y axis, right? Because you can see Y is the vertical axis and all the forces are in Y axis, but they are opposite to the Y axis. The Y axis is upwards, as you can see with the arrow, but this force you can see it is down, okay? So it is opposite to y-axis, so it is minus, so every force is negative along, okay, negative along the y-axis, okay? So this is negative 1000, negative 2000, negative 4000, negative 2000, negative 1000, okay, along y-axis each, okay? So let us begin putting the forces, okay? So let's first put this minus 1000, okay? Now I will go to the force, click on this, click apply, and I will define it by component. Everything is 0 except Y component, right? Y is minus 1000, right? And press enter, right? Let us see, minus 1000, right? I have written minus 100, it's not minus 100, it is minus 1000, okay? Now let us add another force here. Click on force, click on this, click apply, and click on define by components. Click on Y and write it as minus 2000, right? Then click on force, click on this, click apply. I will keep it as component, and this one is minus 4000, right? So let us check again. Now this force is minus 1000, this is minus 2000, and this is minus 4000, right? Let us see, minus 1000, minus 2000, minus 400, right? Okay, then these two forces are opposite of these two, okay? Minus 2000 and minus 1000, right? So I click on force, click here, click apply, define by components, minus 2000, and click on this one, click apply, define by components, and how much is it? It is minus 1000, right? Okay, now let us check everything again. This is force 1, 1000, minus 1000, then we have minus 2000, then we have minus 4000, then we have minus 2000, and then we have minus 1000, right? So everything is okay. Now we have applied the supports. Okay, these are the supports, and we have also applied the forces, right? Now we have done everything. Now it is time to get the solution. Okay, now in the solution I will right click and click on insert and beam tool. Where is it? Here. I will insert the beam tool, and in the beam tool I will also insert deformation total. Okay, now when I click on the solution and click on solve, it will give the results. Okay, here you can see 85%. Okay, it has done. Okay, so when you click on direct stress, here you can see these are the stresses, right? So what is the stress? Now the maximum stresses are here. You can see the maximum stress is 3.99 times 10 to power 5 Pascal, right? And the minimum is minus 7.64, right? And they are the top members and the side members. Okay, now the negative means these blue members, they are in what? They are in compression, and positive means these members are in tension. Okay, now let's see the total deformation. The total deformation is, of course, these 2 points, they are supports, right? So the deformation will be 0 at the supports. Then we have maximum deformation where if you remember, here this is the midpoint, here it was the maximum force. I will show you here. The maximum force is 4000 Newton at the midpoint. Okay, so we have the maximum deformation at this point here. Okay, so you can see the maximum deformation is 0.000148. Now you can see it is in meters. Okay, so that's it. So if you have any doubts, you can comment, and if you need help in any of your Ansys projects, you can contact me. And that's it for today. See you in the next class. Thank you.